Hello everyone. In this video I'm going to be doing a short example for the method of undetermined coefficients in the case where our forcing function, the right hand side, is a polynomial. Now, in the case where we have polynomial expressions, one of the things to keep in mind is that much like when we do polynomial long division, it is necessary for us to not skip any of the terms in the expression. So our guess for what the particular solution is going to look like in this case needs to make sure that it has a term for t, even though there isn't one that shows up in this expression. Because as we see, when we compute the derivatives of this, if I had skipped the term with t, it would come up when I differentiated the term for t squared. So here y prime of t is going to be equal to 2 times a times t plus b. And the second derivative of this expression is going to be equal to just 2 times a. At this point, we plug this into our differential equation, and the idea is that we want to try to figure out what our coefficients a, b, and c are all going to be equal to. We plug in 2a for y double prime. We plug in 2at plus b for y prime. And lastly, plugging in at squared plus bt plus c for y. And then on our right hand side, we are going to have t squared minus 3. The next thing that we want to do is collect like terms on the left hand side, because our goal ultimately is to create a system of equations that's based on matching the coefficients of the polynomials for both sides of the equation. So let's start by collecting terms for t squared, which is pretty easy to do. We just see 3a times t squared here. And then next up, we want to get the expression for the coefficients for t. We're going to get negative 8 times a from this term here. From this term, we're going to get 3 times b. And then lastly, we have our constant terms. We're going to have 2 times a minus 4 times b plus 3c. And this is all going to be equal to t squared minus 3. Matching the coefficients of the two sides of the equation suggests a system of equations. We're going to have 3a is going to be equal to 1, the coefficient on t squared. We're going to have negative 8a plus 3b is equal to 0, because there is no factor of t or term involving t on the right hand side, so its coefficient is 0. And then lastly, we have 2a minus 4b plus 3c is equal to negative 3. Now, because of the way that this system of equations is set up, we can solve for a and then substitute that into the second equation to solve for b, and then likewise for the third equation to find c. So we're not going to use any of our fancy techniques and just go for direct solutions here. Clearly, a is equal to 1/3. And then we can plug that into the second equation in order to help us figure out what b is going to be equal to. So we get 8/9 for b. And then lastly for c, we have that 3c is equal to negative 3 minus 2a plus 4b after moving everything else over to the other side. We're going to get negative a minus 2/3 plus 32 ninths after plugging in a and b. We want to express all of this with common denominators. So here we're going to get negative 27 over 9 minus 6 over 9. And of course we have plus 32 over 9 here. This gives us negative 1/9. And then we need to divide by 3 in order to find c. So we get negative 1/27, which tells us that our particular solution for this differential equation is equal to 1/3 t squared plus 8/9 t minus 1/27. All right, thanks for watching.